Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we discuss the second part of the chapter, Provoked Nuclear Reaction. We recall the objectives of this chapter. The first objective was already discussed in first part on how to determine the mass defect and the liberated energy. The second objective is to identify the characteristics of fission nuclear reaction, and in third objective, we discuss how to identify the chain fission nuclear reaction. And the last objective is to identify the characteristics of a fusion nuclear reaction. In this video, we discuss objective 2 and objective 3. The stimulated nuclear reactions are reactions that needs external intervention to be occurred. There are two types of this stimulated nuclear reaction, fission and fusion. Note that the laws of conservation of mass number, the atomic number, and the total energy are also applied in stimulated nuclear reactions like the spontaneous one. The interaction of a particle with a heavy nucleus called fissile causes the splitting of this nucleus into two lighter nuclei with emission of another particles and radiation, as shown here in this animation. Such kind of reaction is called nuclear fission reaction. So, by definition, the nuclear fission is a stimulated nuclear reaction where a heavy non-stable nucleus called fissile nucleus splits to two lighter nuclei due to the impact of a particle. Note that the most suitable particle to undergo nuclear fission is the neutron, since it has zero charge, so it doesn't deflect when approaching the positively charged nucleus. An example of fission reaction is shown here. We have a neutron with a small kinetic energy interacts with a heavy nucleus called uranium, and this heavy nucleus becomes unstable nucleus called fissile. An example of fission nuclear reaction is shown here. We have a neutron with a small kinetic energy interacts with a heavy nucleus called uranium-235. This uranium becomes unstable nucleus called fissile and ready to split into two light nuclei and particles. In this reaction, the neutron is called projectile, the uranium-235 is called target, the uranium-236 is called fissile, and the barium and the krypton are called fission fragment. A nuclear reaction takes place when a thermal neutron having small kinetic energy of approximate value 0.025 electron volt collides with the target nucleus and embedded in it, thus forming a new unstable nucleus which is divided into two lighter nuclei and certain number of fast neutrons. Note that if the projected neutron moves very slow, it will bounce back and thus no fission reaction takes place. And if the projected neutron moves fast, it will penetrate the nucleus and also no fission reaction takes place. Now we discuss the third objective, which is the characteristics of the chain nuclear fission. As shown from this animation, and upon splitting of a fissile nucleus after being bombarded by thermal neutron, two fission fragments are formed and multiple small particles called neutrons are also produced. These produced neutrons will undergo another fission reaction if they have suitable value of the kinetic energy. So, a chain fission reaction is a process in which neutrons released in fission that produce an additional fission and the process repeat. In general, one fission liberates more than one fast neutrons. These neutrons should be slowed down in order to start a chain reaction. A moderator is a material used to slow down the neutron produced from fission. In a nuclear fission reaction, the produced nuclei, particles, and radiations appears in different forms of energy. We have kinetic energy of the fission fragments and the produced particle, and also we have electromagnetic energy of gamma radiation. Let's practice on this part and we solve application 1. In the given of this application, we have the adjacent figure that represent a nuclear reaction. The mass of each particle and nuclei are also provided. In the first question, we have to specify why this nuclear reaction undergo chain nuclear reaction. We say that since 3 neutrons are produced in each fission reaction and the process will repeat. In the second equation, we have to write the nuclear reaction and to determine the charge number of barium. We have a neutron interacts with uranium-235 to give a krypton and barium with emission of 3 neutrons and gamma radiation. To determine Z of barium, we apply Sod's law, then we get Z equal to 56. The third equation asks, what is the condition on the incident neutron needed to satisfy this equation? We say that the energy of the incident neutron must be around 0.025 electron volt. In the fourth equation, we have to indicate the form of energy that appeared in this nuclear reaction. So we have kinetic energy of the produced neutrons and the fission fragments. Also, we have electromagnetic energy of the gamma rays. The last equation of this application asks us to determine the liberated energy of this fission reaction. To calculate the liberated energy, we have to calculate first the mass defect. So delta M is equal to the mass of the reactant minus the mass of the product. We substitute the values and we get 0.18616 U. For sure, we have to convert this one to kilogram by multiplying it by 1.66 times 10 power minus 27 kilogram. So we get 3.09 times 10 power minus 28 kilogram. The liberated energy is defined as the product of the delta M times the square of the speed of light in vacuum. We substitute the values and we get 2.78 times 10 power minus 11 joule. But we have to find this value in mega electron volt. So we divide it by 1.6 times 10 power minus 13 joule, and then we get 173.75 mega electron volt. In the summary of this part, we have seen that the nuclear reaction is a stimulated nuclear reaction in which a heavier nucleus is divided into 2 lighter nuclei under the impact of a neutron. The energy of the incident neutron should be about 0.025 electron volt. Also, if the incident energy of a neutron is large, a moderator can be used to reduce it. And also, we discuss a chain nuclear fission that takes place due to emission of multiple neutrons. As usual, I recommend from you to watch this video many times and to contact your teacher for any further information. Wassalamu alaikum wa rahmatullahi wa barakatuh.